Okay, the last thing we're kind of reviewing today is we're going to review exponential word problems. So here's the nice part about exponential word problems. They all follow the exponential equation we learned, which was y equals ax b to the x power. So they all follow this kind of model, with a being your starting point and b being your growth. So we're going to see, and generally for these things, you have a principal, which is your starting point. It's going to be 500. And this is going to increase by 3%. So if you have to increase by 3%, you always start with 100%. That's always your starting point. You always start with 100%, and if we increase by 3%, we get 3% more. So we grow by 103%. So my growth would be 1.03. And that x would just be for how many years? So the years would be 10. So what I would find is, for this word problem, that my starting point is 500, my growth is 103%, and I would go for 10 years. So then we just plug this information into our calculator and see what we get. Which, when we spit all that out, we get $671.96. In this second example, it's the same kind of thing. So again, we're going to focus on from this form right here, with with a being our starting point. So our starting amount is 100. This team, we decrease by 7%. And again, we always start with 100%. But if you decrease, instead of going up, we're going to go down. So we go down 7%. So we're only left with 93%. So since we're only left with 93%, that will be our rate. So I start out with 100. I times it by 0.93. And I do that for 5 years. Again, we're going to plug this whole thing in to our calculators to find the answer. And when we do that, we should see that this becomes $69.57, which makes sense because we are decreasing. The percent or the rate is depreciating or going down. So the big thing that you want to do is make sure that you know if you're increasing the percent or decreasing the percent. In this last example, again, this is going to be an exponential example. So we're going to use the same form. We start with 30 bacteria, so our A value is 30. And this time, it doubles every hour. And so how you double something is you times it by 2. So this time, we don't have to change our growth rate into different percents because it's not a percent, it's an amount. So it's twice as much. So it's going to keep doubling. And then they say it's for 7 hours. So we plug it in for 7. Again, we plug this value into our calculator just to see what we will get. And if we do that, we should end up getting 3,840 bacteria. So this would be my final answer for what I get. So again, we always use this form, ABX, with A being your starting amount and B being your growth.